Question number 3, what is the specific heat of 250 grams of an unknown substance that requires 750 joules to raise its temperature by 40 degrees C? Okay, in this one we have a value for Q. And we have a mass of 250 grams. Raising its temperature by 40 degrees, so it's giving us the delta T, 40 degrees. And it wants us to find specific heat. So we take our equation and we rearrange it. Oops. To solve for specific heat. And to do that, we're going to divide both sides by m and delta T. That causes the m's to cancel over here and the t's to cancel over here, and we get Q over m times delta T equals S, or specific heat. So I'm going to change sides here. And my Q is 750 joules. Mass is 250 grams. And delta T is 40. When I punch all those numbers in, I get 0.075 joules per gram per degree C. And those are the appropriate units for specific heat. So that's the final answer for number 3. Number 4 says, for the following reaction, barium oxide plus sodium trioxide yields barium sulfate. The delta H is negative 213 kilojoules. How much energy is released if you react 350 grams of barium oxide with excess SO3? So what this reaction is saying to us is that we have 1 mole of barium oxide, and when that 1 mole reacts with SO3, the heat of that reaction is negative 213 kilojoules. That's just for 1 mole of this stuff. We have 350 grams of it. So what we need to do is figure out how many moles of it we have. Then we can use our ratio to determine what the delta H is. So, of course, the first thing we have to do is we have to get our molar mass. So we need the weight of barium and we need the weight of oxygen. By now you probably know from memory that the weight of oxygen is 16. And the weight of barium is 137.30. That's what it is on the chart I have right now. So we add those up. Okay. Sorry for the messy writing. So the molar mass of barium oxide is 153.3 grams per mole. Okay? This is our conversion factor. So now we take what we're given. What we're given is 350 grams of barium oxide. So you start there. Draw your line. Use your molar mass to convert your grams to moles. So grams are on top here, grams have to be on the bottom here. 153 grams per 1 mole of barium oxide. Okay. Now you're going to punch that into your calculator. I'm going to have 4 significant figures, so 2.283. Okay, and that's moles of barium oxide. Okay, so now we have over 2 moles of barium oxide. So we know that this delta H is going to be more than twice this number, because this is the delta H for 1 mole and we have 2.2 moles. So we just take our moles that we've calculated, 2.283, and we use our ratio. This is 1 mole at this amount of heat. So 1 mole of barium oxide produces negative 213 kilojoules. Okay, we're going to be down to 3 significant figures in our final answer. So punch that in. I get negative 486 kilojoules. Okay, so that's the answer to number 4. Number 4, calculate the value of delta H for the following reaction. PbCl2 plus Cl2 yields PbCl4. And we want to figure out what the delta H is on this. This is a Hess's law problem. We're going to figure this out from using 2 different steps of the reaction. So we go through just like we've done before, and we find all of our reactants and all of our products and mark them. So the first thing we're going to look at is PbCl2, and we need to find that down here. And it's right here. This is in our products down here. It's in the reactants up here. So we can't change this one. We have to change these down here. So that means we're going to have to reverse this reaction. When we reverse it, we're going to reverse the sign on the delta H. But let's find the rest of them first. Here's Cl2. And we have Cl2 here. We have Cl2 here, and they're both on the reactant side, although this one we know we're going to reverse. So probably part of those are going to cancel out. So we're not going to worry about that yet. And then the last thing we have is PbCl4. And that is right here. So that's on the product side and that's on the product side, so that one's fine. So I'm going to rewrite these. The first one stays just like it is. Plus 2Cl2 yields PbCl4. Second one has to be reversed. PbCl2 yields Pb plus Cl2 gas. Okay. Now we've got to put our delta H's over here. This one's going to reverse the sign. Now we have 359.4 kilojoules. All right, now let's see what we have. We have a Pb over here and a Pb over here. Neither one of those are in the original equation, and so we can cancel those because we have one on each side. We have PbCl2 here, which goes with that. We have 2 Cl2 here on the reactant side. We have Cl2 on the product side, so we're going to take this one away. When we do that, we have to take away one of them over here. So that's going to leave us with 1 Cl2. And then for our product, we have PbCl4, which is right there. So we end up with PbCl2 plus Cl2 yields PbCl4. Okay, and let me go back and put in the little symbols for everybody. Okay, So now we just take these two and add them together, remembering that the first one is negative. So essentially you're subtracting. And I get 30.2 kilojoules. Okay? And that is the answer to number 4. That is the delta H for the original equation.